what is an index and why do you have it? An index is key values in some sort of order with row IDs, key values and row IDs. The row ID, remember, if I connect to the demonstration schema, Scott, and I select star from depth, I see these 4 rows returned. But in fact, there's more to it than that. I can select row ID, depth no, dname, lock from depth. And we see this. This is Oracle proprietary. It's nothing to do with ANSI SQL, nothing to do with standards. And that's why when you just run that command, you don't see it. So we've got the Oracle proprietary row ID. And the row ID is the unique identifier of every row in the entire database. Encrypted within it, the first 6 bytes identify the object to which the row belongs, in this case, scott.depth. The next 4 bytes identify the physical file within which the row resides. Then you've got 6 bytes that identify which block within that file the row is. And the last 2 bytes give you the offset into the block. And looking at this table is so small that all 4 rows are, of course, in the same object, they're in the same file, they're even in the same block. Now, the only difference is their location within the block. So that row ID is the physical location of the row. And the fastest way to get data in Oracle database is this. Select star from depth where row ID equals. Hey, that was fast, wasn't it? Now, that is the fastest way to retrieve data in an Oracle database because you're telling Oracle physically where to go. I hope none of you ever do that. There are quite a few reasons why that is pretty bad code. But in an index, that's exactly what happens. The index contains pointers to table rows. So if I were to use an index for this, I'll just enable the auto trace on, the auto trace facility. If I select star from depth where depth no equals department 30, what Oracle has done, it's identified that there is an index on that column and has decided that it's a good idea to use it. Questionable decision, but Oracle has decided to use the index from department number. It searched that index to find department 30, and associated with the key value 30 is a row ID for the sales department. And that's what you see here, searching the index, then table access by index row ID. That is Oracle doing what I did manually with that. Oracle's allowed to do it. We shouldn't. So that's the beginnings.
So, I'd like to jump in here. Is everybody familiar with AutoTrace? Is that what you used there, John? I wasn't watching your screen for just a split second.
Yes, I just switched on the AutoTrace facility.
Yeah. Questions on AutoTrace? Is everybody good with AutoTrace? It's a fantastic SQL tuning tool. Lets you see the explain plan. The row ID is in, I think, base 16 it is. If you saw my chat, I mentioned that. So you see a lot of A's, the uppercase A and the numbering system in the row ID. The uppercase A is equivalent to a 0 in that notation. So you'll see a lot of those. Then you did an auto trace, and then we have the explain plan. So, we cover this in great detail in the SQL tuning class, but I will post a link to a video tutorial of John explaining how to read an explain plan. And even if you're proficient at reading an explain plan, I recommend you take a look at this just to make sure that you're reading your explain plan correctly. I listen to it every once in a while myself, just to get my feet back on the ground. Okay, everybody's comfortable so far? No questions? Why, then, you got to be careful if you say there's no questions or if you don't ask me a question, because then I'm going to ask you a question. John said he didn't want you to use the row ID in your SQL statements. Why? If it's so fast to use the row ID in a SQL statement, why wouldn't you grab the SQL ID, save it away, and when you need the row again, go back and get it? Wonderful, wonderful, wonderful. That's right. Because it can change. Why can it change?
I, in fact, take a different approach there, in that I say you shouldn't use it because it isn't part of the ANSI SQL standard. But what you've put, what I see there in the chat, is real practical reasons for why you should never do it.
Yeah, DML can change it. You cannot be sure that the row ID will always be the same. There are architectural reasons that the row could move to a different segment, and that's just the way it is. And when we have more time to talk about it, we'll tell you. Back to you, John. Thank you very much.
Okay, one last point on the auto-trace facility I'm using. Dave was very precise in his terminology. Auto-trace shows you the explain plan for the statement. Never forget that. This might not be the execution plan that was actually used. It might not be the same as what was used. It is merely the explain plan for that statement, not the execution plan that was used. In this case, it will have been. But always remember, it might not be. So that's what an index beginning, what it's for, what it is. Why do you do it? Well, performance is the headline usage, but it's more than performance. It's also scalability. There are quite a few cases where Oracle itself needs indexes, particularly to do with concurrency. Foreign keys causing table locks is a classic example of that. So it's scalability, high levels of concurrency, as well as performance. But the headline usage is undoubtedly improved performance by reducing how many block visits the statement needs. Oracle needs indexes to enforce unique or primary key constraints. There are several reasons. But look at this. Don't create indexes unless you really are sure you need them. Take a look at a simple example. I'll create a little table. Create table T1, C1, number. Right. Set timing on. Insert into T1, select row num from dual. Connect by level less than, say, 1,000,000. Oops, better make it smaller than that. I'll put in, truncate the tape, let's do it again. I'll go for 500,000 rows. I'll insert 500,000 rows into that table. 0.37 seconds. Okay, drop the table. Oops, dropping the table just to make sure that I'm comparing with a level playing field, as it were. Create the table again, and this time I'm going to index it. Create index, I1 on T1, C1. Absolutely straightforward index. And now I'll insert my 1,000,000 row, my 500,000 rows. Previously, 500,000 rows, 0.37 seconds. Let's try it now. 1, 2, 1.7 seconds, 1.0. Ooh, undo segment is getting worse. Didn't even finish it. Add another data file to that table space. And then we'll try again. Okay, insert my 500,000 rows. 1, 2, 3. 3.14 seconds to insert those rows, whereas previously it was 0.37 seconds. That's what, 8 times as slow, nearly 10 times as slow. Isn't that an incredible performance degradation? Nearly 10 times as slow, simply because I've indexed the column. And that's an absolutely straightforward index, as simple as it can possibly be. It's a single column index on a numeric column, and performance is degraded by a factor of nearly 10. That's why you've got to watch your indexes. Indexes are terrible for the performance of DML. They may help your selects, insert, update, delete. Oh dear. So, There's also a bit of maintenance for them, and of course there's space. So indexes can be fantastic. Use them with extreme care though, and never forget how much they can slow down your DML operations.